Imagine waking up tomorrow on a planet 5 times bigger than Earth. Same sun. Same distance from it. Same rules of physics. Just bigger. No asteroid. No alien invasion. Just one number changing, the diameter of the planet beneath your feet. It sounds harmless. A bigger planet, more room to live, right? Wrong. Almost everything about how life works, how we move, how we breathe, how we build, even how tall we grow, is quietly held together by the size of the planet we live on. Change that one number, and civilization as we know it might never happen at all. So let's actually do the math. What would a 5 times bigger Earth look like, and could humans even survive on it? First, the numbers. If Earth's diameter were 5 times larger, its volume wouldn't just multiply by 5, it would multiply by roughly 125, because volume scales with the cube of size. Mass increases dramatically too, assuming the planet is made of similar material. And more mass packed into a bigger sphere means one thing above all else: gravity gets brutal. Depending on density, surface gravity on a planet like this could end up somewhere between 2 and 3 times stronger than what we feel on Earth right now. That doesn't sound like much on paper. In practice, it changes everything. A person who weighs 70 kilograms on Earth would suddenly feel like they weigh over 150 kilograms. Every step. Every staircase. Every time you stand up from a chair. And gravity isn't the only thing that scales up. Atmospheric pressure increases. Ocean depth increases. Wind patterns shift. The entire planet becomes a heavier, denser, more punishing version of the world we know. Human bodies are built for Earth's gravity, and evolution doesn't forgive a jump like this overnight. On a planet with 2 to 3 times the gravity, tall, slender bodies become a serious disadvantage. Standing upright at full height puts enormous strain on the spine, joints, and heart, which now has to pump blood against far greater resistance. Over generations, evolution would likely favor something very different from how we look today: shorter, stockier bodies, closer to the ground, with thicker bones and denser, more powerful muscles, built more like a bulldog than a basketball player. Hearts would need to grow stronger to push blood upward against the pull. Bones would need to be denser just to avoid fracturing under everyday stress. Even simple things, jumping, running, climbing stairs, would require a completely different set of physical adaptations. It's not that intelligent life couldn't exist here. It's that it would look almost nothing like us. And getting from early species to civilization would take a body built to survive being pulled toward the ground 3 times harder than ours ever has to. Land animals would face the same brutal math we just talked about, which means most large land creatures, the way we know them, simply couldn't exist. Elephants, giraffes, even large horses would struggle to support their own weight. Land megafauna would likely shrink, not grow. Low, wide, heavily muscled bodies built to survive crushing gravity. But the ocean tells a completely different story. Water supports weight for you. Buoyancy cancels out most of the extra gravitational pull, which means marine life wouldn't face the same size limits land animals do. In fact, with deeper oceans and higher pressure environments, sea creatures could grow larger than anything currently swimming in Earth's oceans, genuine sea giants, protected from gravity by the water around them. So picture this planet's biosphere: stocky, powerful, ground-hugging creatures dominating the land, and true giants ruling increasingly deep, crushing oceans. 2 completely different evolutionary paths, shaped by the exact same planet, just responding to 2 very different sets of physical rules. Now let's talk about getting off the ground, because on this planet, that's a genuine engineering nightmare. Flight depends on lift overcoming gravity, and with gravity 2 to 3 times stronger, generating enough lift becomes exponentially harder. Wings would need to be dramatically larger, engines dramatically more powerful, and fuel consumption would skyrocket. Commercial air travel, the way we know it, might simply never become economically viable. Rockets face an even bigger problem. Escape velocity, the speed needed to break free of a planet's gravity, increases significantly on a bigger, heavier world. Getting a rocket into orbit here could require multiple times more fuel and thrust than launching from Earth, which means space exploration would develop far later, and far more expensively, than it did in our history. Even ground transportation changes. Cars need stronger engines and more durable structures. Elevators need reinforced cables. Bridges need heavier support columns. Every single piece of infrastructure we take for granted would need to be re-engineered from scratch, just to survive standing still under all that extra weight. Geography itself gets rewritten on a planet this size. Oceans, scaled up along with everything else, would hold dramatically more water, deeper, heavier, and far more powerful in their currents and storms. Coastlines would shift constantly under intensified weather systems, since a denser atmosphere and stronger gravity fundamentally change how storms form and move. Mountains face their own limit. On Earth, gravity already restricts how tall a mountain can grow before its own weight causes it to collapse under stress. Triple that gravity, and that ceiling drops dramatically. Everest, at over 8,000 meters here, wouldn't even come close to qualifying as a tall mountain on a planet like this. It might barely register as a hill by comparison to what the increased crushing pressure allows to form. Even continents would behave differently. Tectonic plates, under far greater pressure, could move and collide more violently, reshaping coastlines and mountain ranges on a faster, more dramatic timescale than anything in Earth's actual geological history. So, could humanity or anything like us actually build a civilization on a planet like this? Probably not the way we did. Every technological leap we've made, flight, space travel, tall buildings, even simple things like running or climbing, assumes a very specific, very forgiving gravitational environment. Take that away, and the entire ladder of progress has to be rebuilt from a completely different starting point. Intelligent life might still emerge. But it would be shorter, stronger, more grounded, literally and figuratively. Its cities would hug the earth instead of reaching for the sky. Its impossible dream wouldn't be walking on the moon, it would just be getting off the ground at all. It's a strange thing to realize, the very fact that we became who we are, that we fly, that we explore space, that we built skyscrapers, depended entirely on one quiet number nobody ever thinks about. The size of the rock we happen to be born on.